Today I'll be talking about how you can debug notebooks and Python scripts in JupyterLab. First of all, just a quick introduction. My name is Karla Spuldaro. This accent you hear is from Brazil, where I'm from originally. Now I live in Canada, in the city of Ottawa, much colder than Brazil, but to be honest, I love the winter. So so here I graduated in computer science early last year. Because of COVID, we didn't have a graduation ceremony, but that's okay. So after graduating, I started working for IBM, where I am a software developer for about a year now. And I work for the Code 8 division, which stands for Center for Open Source Data and AI Technologies. So a lot of us there work on projects of what's called the Jupyter ecosystem. So like Jupyter Notebooks, Jupyter Hub, JupyterLab, and so on. They're all open source projects. And my team specifically is focused on a project of AI-centric extensions for JupyterLab. We call it Elira, and I'll be talking a little bit about it later on. And here are all the places you can reach me and stay connected. This is our agenda for today. We'll have a JupyterLab quick introduction. Then I'll talk about debugging at a high level. Then I'm gonna jump into debugging notebooks, then introduce you to the Elira project and how it can help debugging Python scripts. And then lastly, I'll show you how you can get involved with all these projects. Okay, so data says that there are over 3 million public Jupyter notebooks available on GitHub, and roughly a similar number of private ones too. So that's how popular notebooks are, especially in the data science domain. So if you work with Python, there is a chance you might have heard of Jupyter Notebook before. It's an open source web app that allows you to create and share documents that may contain live code, cool visualizations, and narrative text, as we see here. It is very popular, in particular for manipulation and documentation of workflows for data science, machine learning, and scientific computing. It's also called now the classic Jupyter Notebook. Then JupyterLab, should I move this? Can you see it? JupyterLab is the next generation interface for notebooks. It will eventually replace the classic one. So it provides a more interactive development environment for notebooks, code, and data. So it has a flexible interface. For example, as you can see here, you can display multiple tabs at the same time, while in the classic notebook, each notebook is a different tab in your browser. So here you can get everything together. And not only notebooks, you can have file editors, terminals, consoles. There's a sidebar with a lot of tools, file browser there. It's pretty different. It is designed to be extensible. So you can see a lot of extensions for it. Bringing new features and so on. It has a modern implementation, like it uses NPM-based packaging, TypeScript, React widgets, and it has a high performance, and of course, very cool design for a much better user experience. Now let's talk about bugs. Basically, bugs are errors in your code. So anything that's not expected or that will cause the execution to fail. So say I'm a data scientist and I have my notebook here that goes through the steps of creating an AI model that can compose heavy metal lyrics. So fun fact, yes, I am a heavy metal fan. And fact two, I am not a data scientist. This was actually my school project from my AI class. Which at first, it was all written in Python, like in a Python file. And then I converted it into a notebook. So it has a nicer presentation and it describes all the steps. Okay, so I can run my notebook and I see an error there. So this cell is supposed to load my data set. So I look at the error message there and it says my code syntax is incorrect. So I just forgot something there and I just fixed it and run the code and the bug is gone. So some error messages can be overwhelming like this one and not always that obvious. Or even worse. So like in this example, we're gonna see an example of a silent bug, for example. So I have this number, which is the total patterns that I'm supposed to expect. Oops. Yeah, so what I'm expecting is my total number of characters, which is that number on top of that. Sorry, you cannot see, but it's like close to 1 million minus my sequence length of 100. It should be still a number close to 1 million, but I'm just getting half of that. So this is an example of a silent bug somewhere. Yeah, it's just like not adding up. And I probably need a debugger to see what's going on. So now from here, you can trace your code maybe and try to find what went wrong there manually. You can print logs or you can use a debugger tool. So debugging can be a little frustrating, even if you are a programmer and you deal with it like daily, but often finding the source of it can be harder than actually fixing it. So that's why debugger is so important. Then you might want to use debugger tools to help you out. For example, there's PyCharm, there's Eclipse, Visual Studio. So for that, you will need to take your code out from JupyterLab and bring it to these IDEs and then debug it from there. So there's a lot of steps and extra time required. And if you're not a programmer that has not used these tools before, it also requires extra learning skills. Yeah, so apparently you don't need that anymore because now JupyterLab also has a visual debugger tool that allows you to debug notebook, consoles, and source files. It has all the basic features that you'd expect from a debugger, like a variable explorer, ability to add breakpoints, call stack navigation. It brings JupyterLab closer to being more like an IDE. So it's pretty cool. You can test drive the debugger from a tutorial that you can run on Binder. For this, you don't have to install anything. You just need a browser and internet connection. So you can load the page. It's gonna show you a notebook like this I'm showing here, and you just follow the steps for this tutorial. At the end of my presentation, there's a link that brings you to this binder if you're interested, or I can paste it to the chat later. Then, excuse me. To install the tool locally, you will need the JupyterLab version 3.0 or later Notebook 6 and the Zeus Python kernel. So the debugger only supports Python for now, but it just happens to be the most popular language among notebook users. So I guess they made a good choice. Here's how you can install all these dependencies from your command line. We recommend an Anaconda environment just because you can keep everything contained in one environment. So whenever you need to update any package or uninstall anything, like you don't mess up with the packages in your system. Yeah, so that's why we recommend Anaconda. Just go to anaconda.com and download the package suited for your system from there. And once you have it installed, you can create a Conda environment with this first command here. I don't know if you can see it all. But yeah, I can post the content of this this presentation somewhere, I guess, in a second, confirm. But yeah, so after you install Conda, and then you create a new Conda environment with this first command, and then you activate it with the second command. So the environment is called JL debugger, but you can call it whatever you want. And then once it's activated and all the packages are there, you can run the third command to run JupyterLab. So this will just launch JupyterLab directly in your browser. Yeah, and just one note, like when you're running JupyterLab from your command line, it will pick up all the files of the directory you run this command. So yeah, just a detail, like if you want certain things to work on, you go to the directory you want to work on JupyterLab, and then run this command from there. Okay, so let's go back to my previous notebook bug problem. See, I'm gonna use the debugger here to help me find what's wrong with my expected number of patterns there. So just to give it more an idea of what was going on there. So this model, it learned, like it takes a data set of lyrics of a specific genre. In this case, the heavy metal ones. And then it goes in for training. It has to go character by character, and it kind of has to learn how to make up words. Like, so yeah, I can show you the output in the end. For example, yeah. So in my example, we're looking at yeah, the total characters minus my sequence length. Let's see here. Yeah, so first, after I installed JupyterLab and all the dependencies, now I can switch my kernel to the Zeus Python one. And then I see this toggle button there, and I just enable my debugger, and I see the sidebar. So it contains the variables, call stack, breakpoints, and source panel. So I can go and set breakpoints, and I see them listed there. I can remove them. Yeah, so now I'll set some breakpoints in the areas I'm interested in. So the number of characters, my sequence length, and somewhere in my for loop. So I go and run it, and I see the breakpoint, like my execution just stopped at the breakpoint. So yeah, I can take a look at that. It's highlighted on the first breakpoint. And here are all my variables of that, the state of my code at that point. And here's my call stack where I can choose to play, stop, step over, into, and out. And here is the source code, which is just a snippet of my code at that point. Excuse me. Yeah, so from here, I can skip to next or go to my next breakpoint. And if I continue, I hit my for loop. So I look at the variable there, my counter, and I see on the next iteration, it skipped to 2. So I keep going, and I see it's skipping every other counter. So apparently I found a bug, like why my number was like just going half of what I expected. So I can go there and fix it, save. I can stop the debugger at that point and then just run again. And yeah, I'll just look at my counter again. So now it goes from 1, 2, 3. So it's going as expected. Yeah, I just continue from there. Looks like I fixed it. Yeah, so now I can look at my output here, and it's close to 1 million, which is what I expected. So yeah, the debugger just helped me fix my silent bug there. Yeah, so my model can be a bit more smart now. So I don't know if you can see very well, but like just an example of this output is just funny to see like how the model trains and like come up with words. For example, it's like this lyric looks like, well, the sons of the night, now our blood runs into the ocean. Tomorrow we're gonna night the light. I don't know what that means, but it came up with that word. So like some words just don't make sense, but it just needs more training. Yeah, but it's just pretty fun to watch. It was a fun project to work on. Whoops. Okay. So if you're interested in understanding how the debugger works, this protocol diagram shows how the communication happens between the user interface, the JupyterLab application, and the kernel, which is the server process responsible for compiling and executing the code you write. As I mentioned, for now, the only kernel that implements the JupyterLab debugging protocol is the Zeus Python kernel. When you install JupyterLab by itself, the default kernel installed is IPython. So you can run Python code in either a notebook or open a console to run Python files there. And you can always manually install other kernels in many different programming languages as well. So if I want to run a JavaScript notebook, I can install a JavaScript kernel. Simple as that. Then what's Zeus Python kernel then, and why do we need it, right? So it's still a Python language kernel, but Zeus-based kernels are a lot lighter, which makes it a lot easier to implement new features on top of it. So that's why they chose it to implement the debugger protocol for JupyterLab. The downside is it might have some limitations with a few Python libraries it can recognize. But for some of them that used to be missing, like matplotlib or magic commands, they're now supported. So it's still very close, like feature-wise compared to IPython, and there's still work being done to fill any gaps. So following this flow, first, whenever the user opens a notebook, JupyterLab checks if the debugger is supported by the selected kernel spec. Then if it is, it displays the toggle button to enable it, as we saw in the demo. And we can also see what happens when the debugger hits a breakpoint. So the user triggers the run cell event or execute cell. Then JupyterLab requests the kernel to execute that code. The code is executed. Then it hits a breakpoint. And at that point, the execution is suspended and the kernel stops at that event. Then the stack trace is requested, the kernel responds with it. Then JupyterLab takes it and currently displays the highlighted line in the UI. This is just a very high level protocol diagram implemented for the JupyterLab debugger, but it helps understanding some of the main building parts of it. So what's next for the debugger? As for future enhancements, the plan is to expand the kernel support to more languages. There is also some work started to support the IPython kernel. Oops. And also to add more features that you can also find in other debuggers, like conditional breakpoints, filtering variables, and debuggers also plan to be integrated into the Elara Python editor, so you can easily debug Python scripts too. So now that we started talking about Elara, I'll just introduce you to the project. So Elara is a set of JupyterLab extensions. It focuses on to make the AI development like easier and more productive. So what do we have? It has for example, a pipeline editor. So there you can build notebook pipelines and organize your notebooks into a nice workflow. You can run your experiments locally or on a Kubeflow cluster on the cloud. It also has support for Airflow. And it also extends the notebook UI. So you can submit your notebook as a batch job. So remember my AI Lyric Composer notebook? So it takes days to train that model. So having the ability to run it remotely can easily free up my local resources. So that's that's really helpful. Elara implements the Python script editor, so where you can execute Python scripts against local or remote kernel on the cloud. And that's where we plan to have the debugger more integrated. It is also integrated with a third-party extension for language server protocol. So it enables productivity features in the notebook, and the Python editor like provides code navigation, hover suggestions, code linters, auto-completion, variable renaming, like function signature suggestions like this, and so on. I linked there the GitHub repository for that extension, if you're interested. Yeah, another extension from Elara is the code snippets, where you can easily create and reuse pieces of code in your notebook or file editors. So here's an example of creating a new one. You give it a name, description, choose the language, put your code there. You can add tags so you can filter it later on the search. So when you save it, here I have my notebook, I'm just like deleting that cell to show how I can use it. So we have the code snippet preview, and you can just drag and drop into your notebook. And yeah, I can just like run the function of that I just inserted there. And there you go. Elara is also integrated with a Git extension, so you can use Git on JupyterLab, which is very useful. Yeah, so the debugger not only works for notebooks, it can also be used for Python scripts, and this is how you can do it. So you open your Python code, you select XPython kernel as we saw, you enable the debugger, same way as we did in the notebook. You select your breakpoint, select your code, and then you click run from the main toolbar. And then you hit the breakpoint. So that's how you do it in JupyterLab if you don't have a notebook, but you have a Python file. Then what you will expect to experience in Elara, this is how the Elara Python editor looks like now. It has a toolbar where you can easily save, run your code, stop the kernel, and select the different Python kernel options you might have from there. It makes the execution of Python scripts easier and in less steps than what I showed you before. You don't have to open a console or anything before running it. You just click the run button and the editor will execute your code and display the output. So for now, the debugger is not yet fully integrated with the Python editor here, but it is something that we are looking forward to implement soon. Just more integration and less steps for the user. Here are the links for all the GitHub projects we mentioned today. JupyterLab GitHub, there's the debugger documentation, the Elara repository. Yeah, you can always become a part of the open source community and get involved with this project. You can give them a star on GitHub. And if you're interested in helping in development, you can fork the project and start working on them from there. Yeah, so either if you're a user or a developer, any contribution or feedback is always very welcome. So feel free to create issues on GitHub, where issues can be either bug reports you see or improvements that you want to suggest. Yeah, you can also help on code reviews, on open pull requests, and you're more than welcome to join JupyterLab and Elara's weekly community meetings. Sometimes we have demos, you can ask your questions. It's pretty open. You can get to know the people involved and stay up to date with these projects. Yeah, so more information about these meetings you can find in their GitHub pages in the README. Yeah, I also posted links here where you can find us on Gitter if you prefer to chat. What? Yeah. Yeah, that is all. Thank you.
Thank you, Karla. This was a great demo. I've used Jupyter a lot, but haven't used JupyterLab, and I had no idea that it was so full-featured. And the debugging tools are really, really impressive. So thanks for bringing that.
Thank you.
Can I ask, so do you work on this through your association with IBM? Like, is IBM funding the development of JupyterLab?
Yes, so we are at the Code 8. We work directly with JupyterLab, and it's our full-time job. But yeah, so as I said, like my team is mainly focused on Elara, but like sometimes we work on something and we see an issue that can be better resolved in JupyterLab, so we go there and we contribute there instead. And like, yeah, it's just a good partnership. But
that's great.
Yeah. Yeah, I'm open to any other questions.
A quick question. Thank you. This was brilliant. Thank you for sharing. I did not know about Elara, and I'm definitely going to be installing it with my JupyterLab stack, and we'll be using it because it does seem a heck of a lot easier than Visual Studio Code and the debuggers and the code linters that are in Visual Studio VS Code. Have you done comparisons with some of those tools, which tend to be a lot more advanced, and you can add all sorts of extensions in Visual Studio to get very sophisticated debuggers? But again, caveat, in my opinion, in my experience, they're harder to use.
Yes, definitely. Yes, as you said, if you use an IDE, you will see more complex usability there. But the debugger for JupyterLab is still, I would say it's still a baby. Like it has the basic features and it is growing. People are still working on it to expand and to bring it closer to features that we see elsewhere. So yeah, I would say it depends on what you need. It's gonna be enough. But for example, if you want to watch a variable, I don't think they have it yet, but yeah, as I said, like you can always go to their GitHub and suggest new features if it's not already there. Yeah.
Thank you.
I think I'll stop sharing, but if you need, I'll go back.
I just want to comment that I like your high-level diagrams. They're very clear and concise. I like to put things in tables and use as little words as possible since I'm a technical writer. And I just really admire the way that you illustrated that with the table that you created. So,
oh, thank you. That was actually a table created by the developers of the debugger. It had in their somewhere in their documentation of like their architecture, how it works. Yeah, so it's, yeah. it's their work. But yeah, I also found that very interesting. I was like, yes, that's what I needed, because
I have never seen one that nice and clear before. So I just had to comment on it. Thank you.
Thank you.
Can you walk us through when you set up something you did when you the very beginning of this, setting up a new Conda environment with all the right dependencies for JupyterLab with Zeus and Elira? Can you just walk us through, if there's time, can we just repeat that piece?
Sure. Yeah, we can do that now if you want. Share my screen. Maybe I'll have to. Okay. Let me open the terminal. Make it really big. I think it, hold on, I just have to go to the right place. Yeah, so this is my directory of my Jupyter notebooks. So whenever I have something like all my notebooks, I place it here. So if I run the JupyterLab from any other directory, I'm gonna see those files there instead. So let me go back to the steps. Hold on. Okay. So yeah, if I think it's conda.org. I don't know. Do you want to see the link?
Yeah, I was just, if it's all right, I'll just say screen grab for this.
Okay, so yeah, it's anaconda.com/product/individual. Then you go to download. And yeah, from here you select whichever works best for your system. I'm not gonna do that now because I already have it. But yeah, this is how you install it. And then once you have it, you go back to your terminal. So I need whoops, this command.
So it looks like Jupyter, you're installing Conda, you're going to Conda Forge for JupyterLab, at least version 3 or above, and Zeus, because that's not on regular Conda.
So Conda is just a Python environment. It doesn't have Jupyter in it. Yeah, you can use it for any, to install anything Python related and you want to contain it. So it's apart from JupyterLab, like it's not related, but it's what we recommend to use when you install it locally. So this command is actually creating, so it goes conda create, it creates a new environment. -n is the name that you want to give it. So I'll give it like this name here. And that's here, I forgot what this is for, but it's like for Conda Forge. It goes like through a recipe like somewhere and it grabs the dependencies. And if you want like, so it's gonna grab JupyterLab and Zeus Python dependencies, and it's gonna install in the new environment you create. So actually let me just do something here, because I think I already have one with that name. Yeah, I have one with that name. So I'll just give it another one. Oops. Oops, no. Sorry, I need to give it another name. Let's call it debugger. Okay. Yeah, so it's creating a Python environment. You can also select the Python version if you want at this point, but I didn't. I think it's going to install default Python. I think it's 3.6 or 3.7. We can check it later. But yeah, like you can see the list here, it's installing like all these dependencies that might need. Yeah, go ahead.
Sorry, I didn't mean to interrupt. I apologize.
No.
So the debuggers, how good are they with TensorFlow packages and other things for deep learning neural networks, which is what a lot of us are probably doing more work with, just as you did with your heavy metal composer?
Yeah, actually, yeah, as the model I showed you, it uses TensorFlow. So I at least for the example I had, it didn't have any problems with that. But as I also mentioned, there can be some limitations to the Zeus Python. So I'm not sure it's gonna work with every library yet, but it's pretty good, like compared to the IPython kernel that comes with JupyterLab. Yeah.
Thank you.
But I think, yeah. So from here, we have to activate our environment. Yeah, that's what I did. And then it runs JupyterLab from there. So it's gonna open the browser. It should. Sometimes it takes a while. Yeah. So this is how it looks like. Yeah, it opens your browser and you can, open notebooks. Let me see if I have some samples. A better example. Yeah, so this is a Python notebook. I already have it. Yeah, you can change the kernel to Zeus Python. And then you see the debugger button here. You can enable it and start using from here. Set a breakpoint, run. You should stop. Run all stuff. Okay, yeah. Yeah, so this is our breakpoints and you can just, yeah, walk through your variables and yeah.
Very cool. Perfect.
Any other questions?